Hello everyone. Today we are going to be going through how to solve some cubic equations over the complex numbers. Now we are going to be going through some examples together, and you will notice that the method that we use to solve cubic equations over the complex numbers is quite similar to how we solve cubic equations over real numbers. So let's get started. Let's first factorize p of z, where p of z is equal to z to the power of 3 plus z squared plus 4. Now, we know from our prior work with polynomials that we can use the factor theorem, to figure out our first factor. As a quick reminder, a quick recap, our factor theorem tells us that if a is a solution to our polynomial, then p of a, so when we substitute a into this equation, it would equal 0. So what we can do is we can use trial and error to figure out the first factor of p of z. So let's try that now. Let's try p of 2 as our first substitution. So if this equals 0, then we know that z minus 2 would be a factor. Now let's work through this to determine whether it actually equals 0 in the first place. So we will substitute 2 to the power of 3 plus 2 to the power of 2 plus 4, which equals 8 plus 4 plus 4. This equals 16, which is not equal to 0. So we know that z equals 2 is not a solution, and z minus 2 then mustn't be a factor. Let's try again, perhaps with p of negative 2, and let's see if this equals 0. Okay, let's do this. So we've got negative 2 to the power of 3 plus negative 2 to the power of 2 plus 4. This would equal negative 8 plus 4 plus 4. And look at that, this equals 0. So p of negative 2 equals 0, meaning that z equals negative 2 is a solution. And so z plus 2 must be a factor. So now we can rewrite p of z as z plus 2 times some quadratic would give us our expanded form of p of z, which was z to the power of 3 plus z squared plus 4. So to determine what this quadratic over here is, we would have to use our long division with polynomials. Let's quickly go through this. So we would go z to the power of 3 plus z squared plus 4 divided by z plus 2. So z times what equals z to the power of 3? We know intuitively that z times z to the power of 2 would give us z to the power of 3. We will then multiply this z squared into our denominator, and this will give us minus. So we are going to subtract what that gives us. So minus z to the power of 3 plus 2z squared. Okay, this would give us 0. This over here would give us z squared minus 2z squared, which would be negative z squared. And the rest of the equation would remain the same. That would be plus 4. Now we will ask ourselves again. So z times what will give us negative z squared? Again, intuitively, we should know by now that z times negative z will give us negative z squared. Okay, again, we will multiply this negative z into our denominator, and that would give us negative z squared minus 2z. Adding these together, this would equal 0. And we actually don't have another term with z over here. So we can write this with an invisible plus 0z over here, plus 4. So 0z minus negative 2z would equal positive 2z. And again, the rest of the equation would remain the same, so plus 4. Okay. Once more, we will ask ourselves, z times what will equal 2z. Again, intuitively, we should know that z times positive 2 would give us positive 2z. Multiplying this plus 2 into our denominator, this should give us 2z plus 4. Completing this subtraction over here, this should give us 0. Okay, so we now know that the quadratic over here is actually z squared minus z plus 2. Okay, so we can rewrite our p of z as being equal to the first factor that we determined, being z plus 2. So we determined this using the factor theorem, times the quadratic z squared minus z plus 2 that we determined using long division with polynomials. Now all that we have to do is factorize this quadratic over here. Now we went through how to factorize quadratics over the complex plane in the last video, so feel free to check that out. Okay, so we are now factorizing z squared minus z plus 2. We can do this using one of three methods. Over here, I will be completing the square. Okay, so if I start completing the square, then I have z squared minus z plus b, which is negative 1 over 2 squared minus negative 1, or b, over 2 squared, plus 2. Looking at this part of the equation, we know that this can be factorized into z minus a half squared. Simplifying this part of the equation, we would get negative 1 over 4 plus 2, which would simplify to z minus a half squared minus 1 over 4 plus 2, which equals 7 over 4. Now we can manipulate this equation to write it as a difference of two squares. So we can write this as z minus 1 over 2 squared minus negative 7 over 4. And we also know that this part can be rewritten as minus square root of negative 1 squared. So over here, our negative 1 over here can be rewritten as the square root of negative 1 squared times 7 over 4. We also know that the square root of negative 1 squared can be written as I squared times 7 over 4. And so we can rewrite this entire equation as z minus a half squared minus 7 over 4i squared. Again, we want to make this square very obvious and very easy to figure out. So let's rewrite that as z minus a half squared minus square root of 7 over 2 times I all squared. Okay, now we can use our difference of two squares to factorize this further. So we know, using our difference of two squares, this being our a squared and this being our b squared, that in factorizing this, we would get a minus b times a plus b. Using that method, this can factorize into z minus a half, which is our a, minus our b, which is square root of 7 over 2i. Square root of 7 over 2i. So this factor over here would be z minus a half plus square root of 7 over 2i. Okay, so this is our factorized quadratic. So rewriting p of z, our first factor was z plus 2. And now we can write our factorized quadratic here, which is z minus a half minus square root of 7 over 2i times z minus a half plus square root of 7 over 2i. Now, using the null factor law, this equation should be very easy to figure out. So from this part of the equation, we would get z equals negative 2 as a solution. From this part of the equation, we would get z equals a half plus square root of 7 over 2i. And from this part of the equation, we would get z equals a half minus square root of 7 over 2i as your solution. So our three solutions for p of z would be z equals negative 2, half plus square root of 7 over 2i, and half minus square root of 7 over 2i. Now note over here that these two solutions are actually conjugates of each other. And we will come back to using this knowledge and using this trick to solve more complex polynomial equations. Let's try factorizing a cubic with some imaginary coefficients out the front. So let's try to factorize z to the power of 3 minus I times z squared minus 4z plus 4i. Now, in this case, we can actually factorize, so this is our second method, we can actually factorize by grouping. So what this means is that we can factorize out z squared from this part of the equation, and we can factor out -4 from this part of the equation. So if we were to do this, then we would get z squared times z minus I from the first part of the equation over here. And from the second part of the equation, we're factoring out -4. We would get z minus I from the second part of our equation over here. So here's our first part, and here's our second part. Notice that these two equations in the brackets are the exact same. So we can actually factorize out z minus I from this entire equation. So if we were to factorize out z minus I from this entire equation, we would get z minus I times z squared minus 4. So z squared from over here and minus 4 from over here. Now what we have is our first factor over here and our quadratic factor over here. Now again, we can use the difference of two squares to factorize this quadratic further. So this can be rewritten as z squared minus 2 squared. And we know that we can factorize this into z minus 2 times z plus 2. So our factorized form of this above equation would be z minus I times z minus 2 times z plus 2. Now again, solving this equation should be very easy now. We can use our null factor law, and using the null factor law, this part of the equation should give us a solution of z equals I. This part should give us a solution of z equals 2. This part should give us a solution of z equals -2. So these are our three solutions to the above equation. Okay, hopefully this gave you a bit of an overview on how to factorize and solve some simple cubic equations over the complex numbers using our two methods of our usual factor theorem, followed by our polynomial long division, and our second method of factorizing by grouping. As always, let me know if you have any questions. Otherwise, I will see you next time.